Hello friends, today in this video we are going to discuss the disk architecture. So as we know that the secondary storage what we have studied in the computer architecture, there is a hierarchy of memory. So where we term the secondary storage as nothing but your hard disk. Okay. So as you are completely aware about what is hard disk, why we are using this. So today we will be just understanding how the structure of this hard disk is and how to access a data and how to store a data in this hard disk. That is what we will be all seeing in this today's video. Okay. So let me just quickly just walk you through the contents, what we will be seeing. In this video, we will be covering both your disk architecture and disk access time. Okay, so disk scheduling, we will be keeping it in the next video session. Okay, so going through your disk architecture, so let us just try to imagine this hard disk. Okay, so it is a collection of your disks, collections of your disks, or else if you just want to say that hard disk, as you are aware, their storage of the data will be in form of some structure, right? So how this structure looks is just we can imagine entire hard disk will be consisting of the term called as platters. Okay, so this platter is nothing but we can imagine that. Hope so. You have seen a gramophone, right? On the in that gramophone, you can see that black disk structure. Okay, that black disk structure. When we just keep the read-write header on that disk, which is rotating, your song starts playing. Song is nothing but the data stored on that black disk and which will be converted into your audio signals, right? So that is how you will be just listening to the songs which are there present on that disk. In a similar fashion, our hard disk is a compact storage of these platters. There might be n number of platters in there, which will be stacked, okay, in the form of one, what in the form of the diagram what is represented over here. You can just see here there are three disks which are stored. Now, this disks, whatever is been stored over there, definitely we are having some data in that. But what is the procedure to read that data? To read that data, you can just find here. This is what is called as your read write header. Okay, so whenever this read write head is present on that disk, it tries to read the data which is present or which that read write head is on that location. Okay. But how exactly the data is being stored? It is definitely in the form of some structure, right? So let us understand how exactly in a systematic way that this data is being stored over there. Now, I have told you this hard disk is consisting of what? N number of platters. This n number of platters, each platter is having a upper surface and a lower surface. That means we are having how many surfaces? Two surfaces, top and bottom. Okay, so that is why you can see here there are two readers. This reader will be reading the data on the top surface, and this reader will be reading the data at the bottom surface, right? So these two surfaces are again divided into tracks. Okay, that means if this is one circle on this disk, this circle is what is called as the track. And again, the track is divided into what? Sectors. Okay, so let us just imagine how exactly the system is. Okay, you can just imagine that. I hope you have seen the CD. Okay, so that CD, let us understand in this way. This CD is something which is storing of roughly 8 songs. Let us understand. Okay, this CD is consisting of 8 songs. So for our imagination, I understand it in this way that one song is stored in the entire track, right? So one platter, if it is divided into 8 tracks, each track is consisting of one song. Each track is consisting of what? One song. And that one song, in that one track, okay, I want to store that entire song. I want to store it on entire song. Let us assume that one song is of 4 MB. One song is of what? 4 MB. Now that 4 MB of data should be stored in what? One track. Okay, so let us assume that this is a track, right? This is one track. So in one platter, how many such tracks are, I have told you, we are having eight such tracks. We are having how much? Eight such tracks. This is just an example I'm giving. Exactly, there will be no such eight tracks and all. There might be a number of tracks. Okay. But for your understanding, I have told you that one platter, let us assume that there are eight tracks. Eight tracks, I have told you what each track is consisting of one song. Now, one song is of how many MB? 4 MB, right? That 4 MB of data will be stored in the form of sectors. Will be formed in the form of what? Sectors. That means each sector will be consisting of some KB of data. Okay. So 4 MB of data means what? 1024 KB into 4, right? So those many KBs of data will be there. And one sector might be consisting of some amount of KB of data. Okay. So whenever this read write head is on one such sector, that part of song will be played. Now it should move to the next part of song. That means this should be sequentially read. So how it will be sequentially read? That means there is a limitation for this read write head. That means this read write head can be moving only in two directions, that is forward and backward. It is only what? This read write head moves in only two directions, that is forward and backward. That means this read write head can read first song, second song, third song, fourth song, and fifth song. But I don't have any option of moving this read write head either on the left hand side or right hand side. So how this is managed? How this is managed? Now, this read write head is on this sector. Let us assume that it is on this sector. Now I want to read the data which is there present in this sector. How is that possible? It is not possible until and unless this disk is rotated in either clockwise or anti-clockwise, right? So to rotate this disk into clockwise or anti-clockwise, we take the help of what? Spindle. Okay, so this spindle helps to rotate this disk either into clockwise or either into anti-clockwise so that we can read the entire data which is present on this track. Okay, so now let us assume I am there on the second track. If I want to read, if I want to listen to that entire song which is present on the second track, that means your disk, sorry, your platter will be rotating in clockwise at certain phase, at certain phase. Okay, so that you can easily listen to that song completely, right? So if that read write head is on the eighth track, that means you are listening to the eighth song. Okay. So no doubt these tracks, as and when it is near to the spindle, it will be smaller, and as and when it moves to outer region of the spindle, it will be on the larger side. That is, this track will be of huge size. You can just imagine that the radius of the outer track will be of larger length, and the track at near to the spindle, the radius will be smaller. So I have told you each song is of 4 MB. Then smaller track will be also of 4 MB and larger track will be also of 4 MB. How this is possible? That is only possible by the density of the data what is stored on that track. We will see that later. Okay, how the 4 MB is stored in the smaller track and larger track. That is totally how you compact the data and store it in the sectors. Okay, that is only the logic behind that. We will understand that later. But here we can just make sure that disk architectures can be divided into certain sequence. What is that sequence? First, the disk is consisting of what? N number of platters. Each platter is having two surfaces, and that surface is divided into number of tracks, N number of tracks. Each track is divided again into what? Sectors. And in that sector, we are actually storing the data. Okay. And how to read this data? To read this data, we are having a read write head. This read write head helps us to read the information which is stored on that sector, particular sector. And the limitation of this read write head is what? It can move only in two directions. That is, either it can move forward or either it can move backward. So how to read the information which is stored on the entire track? For that, we will take the help of what? Spindle, which has a power to rotate the splatter either in clockwise or anti-clockwise. Okay, so this is what is all about your disk structure. Clear? So there might be some examples which can be asked on this disk structure, right? So they might ask you that what is the total, data which is stored on a disk? Okay, so let us take one simple example that entire disk consists of 8 platters. It is consisting of how many platters? 8 platters. And I have told you each platter is of how much it is having of how much surface? It is having 2 surfaces. Okay, see here. Let me just take the pointer. Okay, fine. So I have told you that let us assume that in this example, we are having how many platters in the hard disk consists of 8 platters, and each platter consists of how many surfaces? Let us take it as 2 surfaces. And on each surface, we are having what? Tracks. Okay. So how many such tracks are there on this surface? Let us take that we are having 256 tracks. Okay, and each track is divided into what? Sectors. So how many sectors each track is divided into? 512 sectors. Now, in each sector, we are storing what? Data. Okay, now here he has given in each sector, we are storing what is the data size? 512 KB of data. This will be the given data for you in the problem. And they may ask you, what is the total size of the disk? So it is very simple. You have to just multiply all these factors. How many number of platters? 8 number of platters. 8 multiplied by 2 surfaces. And each surface is having 256 tracks. And each track is divided into 512 sectors. And each sector consists of 512 KB. So when you multiply all this, you will be coming up with an answer that is 2 raised to 40, right? 2 raised to 40 bytes. 2 raised to 40 bytes is nothing but 1 terabyte. That is nothing but what? 1 terabyte. Okay. So this is what is all about your disk structure.